Welcome to Math Solutions for All. Today I will give you the assignment solutions 2023 MT14. 1B, question number 1B. A raindrop starts falling from the clouds at a considerably height above the surface of the earth. During the fall of the raindrop, experiences retardation due to air resistance, which is directly proportional to the instantaneous speed Vt of the drop. Write the model equation. Is the system static or dynamic? Why? Obtain the experience for the speed Vt. Discuss the behavior of Vt as the time t changes. Here the raindrop of mass m, raindrop of mass m starts falling from clouds at a considerable height above the surface of the earth under gravity. Here the raindrop is falling under gravity. Let T be the position of the raindrop after time t, where OP is equals to x. Let v be the velocity at p. The equation of motion of the particle at time t is m dvdt equals to mg minus alpha v. The Newton's equation p is equals to mf. Here this is equals to m and f, and the p, what is p? mg is acting downwards, and the resistance alpha v is acting upwards. So mg minus alpha v, where alpha is a positive constant. From this we get cancelling m dv by dt equals to g minus alpha v. Integrating both sides of a, we get this dv by alpha minus g minus alpha v into dt. C is the integrating constant, and 1 by alpha, this is ln alpha g minus alpha v t plus c. So we get this. Initially when t equals to 0, there is no velocity because the particle is starting from initially from v equals to 0. So from 1 we get this c equals to this. Hence we get from 1 and 2 this 1 and 2 this, we want to this get, we will get, and after calculating we get g minus alpha v by g equals to e to the power minus alpha t. Next part g minus alpha v equals to g e to the power minus alpha t. So we get vt is equals to g by alpha 1 minus e to the power minus alpha t. And now the second question is the system static or dynamic? This is the example of dynamic system of first order because we model this example by a differential equation in the time domain, so that it depends on variations of quantities Vt with time t, that is, its behavior depends on derivatives of first order with respect to time t. From 3 we get when time t tending to 0, Vt tending to 0, and when time t tending to infinity, Vt tending to g by alpha. Why g by alpha? What is g by alpha? G alpha is called the terminal velocity of the raindrop. Now the third question 1c is a stone is dropped vertically from a tower of height h. At the same time, another stone is thrown vertically upwards from the base of the tower with a velocity u. Here velocity u. What is the minimum velocity of u so that the stones will meet each other at midair? Now, given that the height of the tower h, one particle is throwing from here and one particle is falling from here. So let t be the time at which the two stones meet, and let x be their height from the ground. We first consider the motion of the stone which falls from the top of the tower under gravity. Since initial velocity of the stone 0, initial velocity here stone is 0, here 0. So we get h minus 0 into 0t into half into 0 g t square. H minus is equals to this. And now the distance covered by the stone that is thrown vertical upwards, x is equals to ut minus half gt square. Why it is minus second sign because G acting downwards, so the upwards direction is negative. We take negative. Adding 1 and 2 we get h is to ut and t equals to h by u. Putting the value of t in 2 we get from 2 value t we get for what we will get these values. H is x is to h minus half into g h square by s square. As the stones will meet each other mid-air when x is to half, then from 2 h by 2 is to half, h minus half g h square by u square, half g h square u square, h minus h by 2, and this 2 to cancel. After cancelling we get u is equals to gh to the power half equals to g. This is the minimum. Then this is the minimum velocity of u. Thank you.